Function vocabulary, extrema, and end behavior. So extrema is an overarching word for minimums and maximums, and there's a couple different types of minimums and maximums. The first type is an absolute minimum. So an absolute minimum is the absolute lowest point on a graph, which can be an endpoint. So if part of your graph ends at an endpoint, it can be the endpoint. So you're looking for the lowest point that you can possibly have on a graph. The absolute maximum is the absolute highest point on a graph and also can be an endpoint. Now the reason that I'm saying something about the endpoint is that the relative or local minimums and maximums cannot be endpoints. So relative or local, I'll be usually calling it the local. The local minimum is a low turning point on a graph. It cannot be an endpoint, and it kind of looks like the bottom of a valley. So you're looking for like the bottom of a turning point. So it would be down there at the very bottom of a turning point. The relative or local maximum is a high turning point on a graph. Again, not an endpoint because it doesn't turn at an endpoint, it ends. And it looks like the top of a mountain. So you're looking for bottoms of valleys and tops of mountains for the local minimum and maximum. Now we say that there is no absolute minimum or no absolute maximum if the graph goes to infinity. So there's no absolute minimum if it goes to infinity in the negative direction, and there's no absolute maximum if it goes to infinity in the positive direction. And that's due to you can't find the top or the bottom depending on if it goes to infinity in that direction. So now we're going to practice this. Now when we name the local minimum or maximum, we use the coordinates so that we could easily figure out what you're referring to. So we're going to write it as coordinates. So remember that for the local, the minimum is like the valley and the maximum is the top of the mountain. And the local minimums and maximums cannot be endpoints. So if I try to find the local minimums, this right here is going to be a local minimum. It's like the bottom of the valley. So the bottom of that valley is at 1, -1. The maximums are at the tops of the hills. So this is a local max, and this is also a local max. So the local maximums are at -1, 3 and at 2, 1. So those cannot be endpoints. Now absolute minimums and maximums can be at endpoints. So if we were to look at this graph, the absolute lowest point of this graph is an endpoint. So this is the absolute minimum, and it is at 3, -2. The absolute max, the highest point, happens to also be a local max. So this right here has two purposes. The absolute highest point on that graph is at -1, 3. Okay, let's try one more that has one arrow in it. So again, local mins and maxes can't be endpoints. We're looking for valleys and mountains. So a local minimum right here, this is like the bottom of a valley. It's where it kind of turns around and starts going back uphill. So that local minimum is at -1, 0. We do not have any other valleys because remember that you cannot have an endpoint as a minimum. So that one only has one minimum. Maximums are the tops of hills. So this is going to be a local max. So that is at -2, 2. This is also a local max. So it is at 2, 1. For the absolute minimum, due to this arrow right there, you're going to write none. There is no absolute minimum because you can never find the bottom of this graph. And the absolute max is going to be, again, the same as that local max. It's not always the case. It's just the case on what I happen to draw. So that's going to be at -2, 2. Okay, now end behavior. So when we have ends of graphs that are going on in infinity, either up or down, and we have no minimums or maximums, they have an end behavior. So we can refer to what exactly they're doing and where they're going based on their end behavior. So the end behavior of a function describes what happens to the y value when the x value approaches negative infinity to positive infinity. So you're going to see this arrow notation here. That means it's approaching. So this graphic right here is really going to help you solidify and answer all of your things. So the first quadrant, if the arrow is going somehow up into the right direction, and it doesn't necessarily have to be located there, it could be over here on the graph, it's just that it's going up to the right. That is when the x value is approaching positive infinity, so it's going to the right, and the y value is approaching positive infinity because it's going right and up. So that if your end behavior is going right and up, it is x is approaching positive infinity and y is approaching positive infinity. So that would be that end behavior. If your line is going to the left and up, so this is going to the left and up, then x is going to negative infinity since it's going to the left, and y is going to positive infinity because it's going up. Down to the left, x is approaching negative infinity because it's going left, and y is approaching negative infinity because it's going down. Then our last one, down to the right and down. To the right means that x is going to positive infinity and y is going to negative infinity. So you really only have 4 options for end behaviors if there is an end of your graph that has an arrow. So these are your 4 options of your answers. So we're going to look at these 2 graphs and we're going to do some end behavior. So as x approaches negative infinity, so that's referring to this one right there because x is the negative infinity is to the left, then what's y doing? It's going to positive infinity, so I'm going to say that y is going to positive infinity. The other side of the graph is this one right here. And as x is going to positive infinity, we know it's positive infinity because it's going to the right. Then y is going what? So if we look at our arrow, it's still going up, so that means that y is also going to positive infinity. So it's going to the right and up, so x is positive infinity, y is positive infinity. On this one, this problem number 2, as x approaches negative infinity is going to be this one over here on the left because it's going to the left. It's going to the left and down, which means that y is also approaching negative infinity. On the other side, it's going to the right and up, so x is approaching positive infinity and y is approaching positive infinity also. So the important part is this graphic right here. Which direction is the line heading in? To the right up, to the right down, to the left up, or to the left down?